So I come from Hydrogen Solutions, and what we work with is scalable, locally produced green hydrogen. And here you see the water running is one of the bases for actually producing. When we talk about green hydrogen, it's renewable energy, and being 50% owned from SKL, a water power production company, or hydropower production company. It's natural to look at the water side, but we also use wind and solar, and we will be looking into the huge possibilities coming from offshore wind. We have through SKL a partial ownership in DVO, deep wind offshore. So, and we have some initiatives going based on that. Let's see if I can get this to go to the next slide here. So very briefly about us, we are, as I said, partially owned by SKL, but also Liquiline. Liquiline, the other company, is a gas technology company coming from LNG gases, and have experience with building bunkering infrastructure and the maritime side especially. So we're focused on being a provider with total provider for hydrogen solutions with a maritime focus. So we want to develop projects, be part of building them, and part of together with others owning them, and doing the support and maintenance and running the plants. We focus on safe and feasible, cost-effective solutions, and have with SKL as a large owner been into large infrastructure projects earlier also, and see that as a big advantage going into hydrogen. And SKL has actually worked with hydrogen since 2013. So been part of this, and financed quite a few studies and looked into different projects like the TC, the possibility in Tyssedal. But now we see, and actually SKL as being part of this for a few years, thought that the market is supposed to, or been looking as on the verge of booming, but it hasn't. But right now we do believe so for the third time since 2013. We look into what we believe are cost-effective and scalable locally produced projects, where we can start off by producing hydrogen from only really small projects like under 1 megawatt of effect, and then being able to scale up. And this is a very good at the beginning now, because it's this chicken egg problem where nobody wants to use or are going into as users of hydrogen because nobody is producing it, and nobody's producing it because you don't have the users. So we have our first project up, and a past investment decision, and we have set the PO, and we're started constructing it at Stord at the energy house there, and I will show this later on. And we have many other projects in pipeline. We're not a very big company. We're only 2 as of now, but we're hiring. We have 3 positions hiring for now, and we work very closely together with our suppliers and partners in doing everything that is technical, and also being able to develop technology through our partners when we don't do it ourselves. So we saw earlier that we have quite different background here. I won't go too deeply into this, but hydrogen comes in many colors, and it's important not to be colorblind. And what we focus on are green hydrogen, which you can see on the upper left side here, which is from, as I said, renewable power and electrolysis. And we are not going into blue hydrogen, or what is where you do use gas reformation, and when you get or take the CO2 storage, you get blue hydrogen, and you get gray if you don't do the CO2 storage. And this is about 99% of what is being produced annually today. We're only focusing on the green hydrogen, and it's many possible usage areas, and that's also what we see when we look at the commercial side of it, is that when you're looking into the client side, you have different needs of and difficulties related to hydrogen. You have, if we look at maritime, we see that if you want to go short range, you can use the compressed hydrogen, and that's one way of store and use the hydrogen. But if you want to go a bit further, you have difficulties with getting all the hydrogen with you. So then you can, instead of compressing it, you take it down to minus 253 degrees Celsius, and you get liquid hydrogen, and that's what we're looking into in a couple of projects now. And then you can get maybe the fast boats and ferries and shipping when you go domestically in Norway. But if you want to go deep sea, you don't get enough energy with you, and you have to look at other chemical storage of hydrogen, and like the possibility of ammonia or liquid organic carriers of hydrogen. And it's also, when you look into this, a very different costs, because it's a lot cheaper with setting up compressed hydrogen, but it's quite expensive to store. But when you go to liquid hydrogen, it's many other different elements that comes to play. It's much more costly to produce in the both the capex and the opex, and you have not the same possibilities as of today when it comes to turning the facilities on and off and energy optimize it. It's a lot more difficult to get the right volumes and the right capex and opex to get the optimal production in the liquid facilities compared to the compressed ones. And when it comes to ammonia, we have barely touched it from our point of view, but we're looking into getting partners on that now to look at more larger plants. What we see when we look into our projects is that hydrogen should be scalably produced, and it should be produced locally. Distributing hydrogen is both risky, at least when it comes to doing it in Norwegian roads, safety-wise and logistically, when you have tunnels and ferries and narrow roads through the Norwegian fjords and over the mountains. So it's not only that it costs a lot to transport it, but it's also a huge safety and logistical challenge. So when you can do the local production instead, you have the same basic cost of energy with some modification, because it's based on where you are in Norway. You can have somewhat different energy pricing, but if you go large distances, it's very costly to transport it. So if we base us on the same renewable energy cost here, said to be 35 øre per kilowatt hour, and you have basically, both in large plants and smaller plants, even way down to below 1 megawatt, you have basically the same effect. So the only cost savings you do when you go large scale is somewhat on the capex side. But what we see when you are able to cut transport, you can do quite heavy in industrial and capex investments in order to actually cut transport. Because when you're producing quite large scale and then trying to just distribute this, it's very costly. And we see that we have managed to get into a couple of projects now that other people have laid to the side because it's for them has been too small. But for us, we see that we can start this with, as I said, below 1 megawatt, and then it's more than enough effect from the local power grid, and we can get this up and running, and we can scale it up as we go along, and as we see that the client's needs are actually larger as well. Because as of now, as I'd said initially, we don't see too much demand. So in every project now, we have to do both a job of selling the hydrogen, but also developing the projects. Because there are many aspects, both as to how to get this into the or to the clients and in what way they need the hydrogen. We see getting up now. I have one of our first facilities here at Stord. We will be producing about 140 tons a year, 400 to 500 kilos a day. This is a project where we have taken the investment decision. We have ordered it, and we have this under construction. You can actually see on the next slide here that here is the facility where the hydrogen will be produced and stored. So we will be producing it here, and we will have pipes going into the energy house where it's 3 test cells. In here, you will have a 3 megawatt Wärtsilä motor running, where they are testing the future of fuels maritime. They will test this combustion engine on ammonia. They will test it on hydrogen mix, different gas mixes. And what we'll do then is when this motor is up and running, our engine, we will use the energy from it and take it back in loop and actually take that into and produce hydrogen with the energy. So we're not connected to the grid when we take that. So we can remove the grid tariffs and get a cheaper energy cost, and we can use this energy instead of just letting the energy go to waste or putting it back on the net. We will use it for hydrogen production. And it's also 2 test facilities in here with fuel cells, where they will test different scenarios and usage of hydrogen in the fuel cells. So it's they will have about 30% of the offtake of what we produce as of now, and we have clients prepared to take the rest. And we also see the possibility of setting up a facility here of a fueling station together with Greenstat that owns this facility together with us. It's them and Altec Services locally at Stord. And it's providing energy then for the test facility for sustainable energy. And we see this as a great way of also displaying it and being able to now get hydrogen commercially available in the western part of Norway for a reasonable price, so that we actually can start running different tests. Because what they saw when they were thinking about investing in this at the test center was that The alternative of producing it ourselves at the test center was buying it. And in Norway, buying and transporting the need of hydrogen to this facility was actually closer to 700 Norwegian kroners per kilo. And we can produce this at a lot lower cost. Basically, with the SIVA support and everything here, we can produce this down to really lot lower costs. I can't go into the specific details of actually this project because we're doing negotiations with them as we speak at what level we're ending up at. But it's no problem deducing a possibility of costs when you see actually what is the costs element here. And what you haven't got here is that you can't take the hydrogen just right out of the electrolyzer, because then it's just the electrolyzers we're using from GHS, it's 35 bars. It's a compressed alkalic procedure, but with the compression, you will get a higher price, and you also need storage. But that's basically what you have in costs element before it reaches the client. Also the piping into the facility, but that's not so expensive. So what you also get when you do production of hydrogen locally as this is that you create values locally. You can create local value chains instead of just transporting it to where you need it. So we see that as a great benefit, and the way we have set up our company is that we also do this in collaboration with local other local owners. So here at Stord, we do this together with SKL as a power company. We do it with Altec Services and Greenstat and Sustainable Energy. And altogether, this helps us both in getting this project up and running, but also getting it to being socially accepted at the places we move into. So when we now move down to Egersund, where we got our Enova grant now, we'll be in the beginning producing 165 tons of compressed hydrogen. We've moved into this project together with Dalarna Energi down at Egersund, and also with Egersund Næring and Havn. So we get, with getting these local owners with us, we also see a great advantage of getting the social acceptance, and also the companies that will help us in actually operating and running the facility on a day-to-day basis, and help us getting clients for both the hydrogen and the oxygen. But what we see is also that when you do produce the hydrogen, you get both oxygen and heat, and getting to use this is not only a way of making the facilities more efficient, but it's also very cost efficient, so that you this will help you in the investment phase of and the running phase of the projects, actually getting to use that. So we do that in both the facilities we're looking into now. We're collecting the oxygen, and we're looking into ways of actually using the heat as well. And we especially see this when we move into larger projects with the possibilities that emerges on this. So here at Egersund, we have secured the facility. We have together with Dalarna Energi, we are moving into a EU project called the Robinson, where they also will use some of the hydrogen in the what will be a a EU project where they look into how to run and operate an island in an energy effective way, and with a lot of different scenarios and solutions. So this would be an interesting session for another time to get them to come and talk about that project. I would guess it's actually a quite unique project. Yeah, we got, as I said, ANOVA support for a preliminary project for hydrogen for maritime transport. So we're looking into how to bunker the hydrogen from the facility to different boats there. It's something that's not been done earlier, so we have some solutions we've looked into, but this is also a very interesting scenario to go into more in detail for another time, because here you have a lot of different possibilities when you do this, both with compressed and liquid hydrogen, and it's no standardized solution, and it should be. You can't go to different harbors with different scenarios everywhere, because then you can't bunker. And we know that a lot of other companies are looking into ways of using containerized hydrogen and just doing that and moving the containers on board. We see a lot of security issues with that without going too much into detail. And we also see that doing a lot of, as I said earlier, local production and transporting of hydrogen on Norwegian roads will be a safety issue going forward. This is the electrolyzers we're based on or using in our initial projects now from GHS, where you can see that we can actually start this with just 140 kilowatts and 65 kilos a day. And what is very interesting on the large scale projects we're going into now is that they come with a new X series of 6 megawatts in a 40-foot container from 2023, which also cuts our capex with at least 30%, making it very efficient. Yes, that's it.